All right, so let me get a share screen going. Today I want to talk about mirrors, shiny objects that reflect their surroundings. Um, and the traditional approach to shiny objects used one of the legacy reflective shaders. These have two textures, a base texture and a CubeMap texture, the CubeMap being the uh, image of the world around them. CubeMaps are 6 images, a front, back, left, right, top, and bottom. They're usually a pain in the butt to make. The skyboxes that we have are all examples of CubeMaps. In more modern Unity, we have something called a reflection probe, an object that creates its own cube map. These can be either baked or real time, generated from the position of the reflection probe. So kind of a snapshot in 6 directions from the position that the reflection probe exists in. The standard shader then takes this cube map from the reflection probe, and if you have a shiny material, that is one where metal and smoothness are both cranked up to 1, it will display that cube map if you're within some specified distance of the probe. If you're not close to the probe, it'll display the skybox. So reflection probes, first of all, are fairly expensive. They're taking pictures all the time. There are a number of optimizations that we can apply to reduce the load that reflection probes put on our scene. First and foremost is the choice of baked or real time. Baked is done once when you bake the global illumination lighting. That at that point it bakes the scene into the reflection probes, and when you run the scene, there's no work at all. So this applies almost no load. Real time lets you show moving objects and changing lights if every frame is selected. That's one of the options under real time. On awake works kind of like baked. It bakes it once when the scene loads, and there's also a VIA scripting option that lets you determine when to refresh the probe. How the probe is refreshed depends on something called time slicing. All faces at once will spread the refresh out over approximately 9 frames. So it doesn't happen instantaneously. There's a certain amount of lag in this. It lags behind what's really out there. Individual faces spreads it out even further onto 14 frames, and no time slicing, which of course is the most expensive, does a full refresh in every frame. A very important optimization is the resolution. I believe we have a choice from 16 up to 2048. These have to be powers of 2, so 16, 32, 64, etc. And our skyboxes are square, so the images, the 6 images are made are 16 by 16 or 2048 by 2048. There's also a high dynamic range option. There's a importance priority, and there's a culling mask that will leave out specified layers, just like we did with the camera. And that box I mentioned that determines the blend range, the area or the volume in which a shiny material will pick up the cube map from that particular reflection probe. Reflections can also bounce from one surface to another, and this can range from 1 to 5 bounces, and 5 is getting somewhat expensive. But if you want mirrors that reflect themselves in other mirrors, this is what you've got to do. Um, the with a irregularly shaped object, static cube map often is fine since we're not that concerned with the reflection being perfectly accurate. So a single baked cube map often suffices. And with reflection probes, we can have more than one probe within our scene. And in this case, the nearest one will be applied to our shiny object. The mesh renderer has settings as to how the available probes are blended. Off will get just the skybox blend probes, uh, only blends the probes, good for indoor scenes. Blend probes and skybox is good for outdoor scenes, and simple has no blending, it just picks the closest one. So if you move from one blend volume to another, you would have an abrupt change. All of these, of course, affect the load. So let me show you examples of these. Here we are, we've got our legacy objects. These are the ones that are picking up a cube map. We've got the shiny object standard. And here I have no reflection probes. And so our shiny material, metal and smoothness, both one, I'm picking up the reflection of my world. But notice I don't see any trees or terrain, I only see the skybox. In this case, I have reflection probes around the scene. I've got these gray boxes around them that kind of show their volume. Escape toggles those on and off. And you can kind of see when I'm outside all of those probes, I go back to just seeing the skybox. But when I put this shiny object inside one of these boxes, I start to see the reflection probe cube map for that object. And over here, there's some overlapping ones. And here, as I move sideways through here, you'll see right there where I'm inside two probes and I'm picking up two reflections of myself in there, one from this one over here and another one from this one over here. And I can even see the shiny object that I'm on. I can put a probe in a moving object. So here I've put a probe in the sphere. And so now I'm getting nice reflections of myself as I move around here and the trees and everything. And the position of the probe, the cube map is reflecting the fact that I'm in different positions. Of course, if I go into one of these boxes, it's now going to combine two of these, and I get this kind of conflicting image where I've got now two copies of myself blended into this reflection. So there are lots of artifacts that you can generate. Having a real time like this costs something in order to have a shiny object, but all of this it sets it up. Here's baked probe. So this one, the light probes are all baked one time, and the objects are picking them up from that baking. Notice I can't see myself in any of these objects because I'm a dynamic object that wasn't there when it got baked. Probes, no sphere, real time. So this is the same, except now they're real time, so I can see myself, I believe, in one of these. There is my character in there. Okay, so that's great, but none of this works very well with mirrors because the probe's position uh, may not correspond to exactly the correct point from which I want to snap a cube map. And we'll talk about geometry in a minute. And the other problem with the reflection probes is that they generate a cube map, but they don't give you any access to it. And um, the um, standard asset materials only pick up their information from reflection probes, not from a material. So we can take advantage of the fact that the Unity cameras have the ability to create a cube map on the fly. They just take a picture, similar to what we did when we did render textures. They can write to a texture, and then we can put that texture on a material, and then we can put that material on a shiny object. And so we can use that ability to generate cube maps where we want them, put that texture on a material, put that material on an object, and have everything look right. Now, for a mirror to show the correct reflection, we have to be precise with the geometry. We have to consider from which point in space we want to generate our cube map. And if you think of an observer looking into a mirror, this is the mirror here, and seeing the reflection of the triangle over here in this mirror, what it looks like to them is they're looking through a window at a triangle that's over here. That's what it looks like. We're seeing this object reflected in the mirror, but looking through the mirror as a window, it looks like the object's over here. So what we want to do is we want to put the camera over here, kind of symmetric from where we are with respect to the mirror, and look out into the world through the mirror and see the object and take a cube map and then map that cube map onto our mirror so that the kind of downward side here of the cube map is applied to our mirror. And the thing that we notice here is that the geometry here obeys the geometry of a perfect reflector. A ray of light that bounces off something comes out in a direction whose angle of incidence and angle of reflection are equal relative to the normal of this object. This is at right angles to the object. This angle and this angle are the same. And Unity provides us with a tool that calculates that perfect reflector. It's the vector3.reflect that takes the incident vector from the camera to the mirror and the normal to the mirror's forward vector in world space, and it generates this perfect reflector. Experimentally, it seems to like minus the normal. Given that, I can then subtract that new P from the mirror's position, and this obtains the point behind the mirror from which we want to snap the snapshot for our cube map. So the render from position is going to be the mirror position minus this new P that we've calculated with the perfect reflector. And now we have the point from which we want to catch a cube map. So we need to set up textures and materials. We can make a cube map texture, temp cube map, which we make with the cube map constructor that takes its resolution. These are squares, and they are powers of 2, 32, 64, 128, etc. The format is 24-bit RGB. This false here is whether or not we want to generate a mipmap. I didn't bother. Mipmaps are lower resolution copies of the texture. So now we have a texture. We need a material to put it on, so I'm going to create a temp material with the material constructor that requires a shader. And I'm going to use the reflective vertex lit shader. I give it a name, a color, the base texture, which I can use for things like dirt and scratches and cracks and other things on the mirror. And finally, I'm going to set the _cube parameter of my shader with set texture to this temp CubeMap texture that I generated, that I made back here. As near as I can tell, the standard shader does not have a slot for a CubeMap, like the _cube in the legacy reflective shader. This is because the standard shader automatically gets its CubeMap from the reflection probe volume in which it's enclosed. And since we're generating our own material with its camera-generated CubeMap, we're left using one of the legacy shaders. And finally, having made the texture and the material, assign it to the mirror's renderer. That's all there is to that. So the camera, the Unity camera has the ability to create a CubeMap on the fly, and I'm going to make a camera on the fly as well. So I have a game object, CubeMap camera object, and I have a camera script, CubeMap camera. I make the object, CubeMap camera, as a game object, and I add to it a camera component that I keep in CubeMap camera. I'll be using that later. And I'll show you an example of doing this with a reflection probe, which does work. It seems to be a little more laggy, and it suffers from ghosting when you have more than one mirror. Now, one key to this is we don't want the mirror to see itself as it's behind the mirror. One thing we could do is put it on a plane. A plane is one-sided. We can see through from the back, but then you couldn't have the mirror on a wall or have a frame for it. So I'm going to use this trick with the culling mask. With that camera culling mask, I'm going to set it to ~1 angle bracket mirror layer. Now, this is a trick that uses the angle bracket left shift operator. This shifts the first operand, the 1, by its second operand, the layer that the mirror is on, and then it reverses it with the tilde operator. And this way, I'm culling only the game object that my CubeMap camera is attached to. There are 32 possible layers, the 32 bits of an ordinary number. So we're taking the 1 and we're shifting it to the left by the layer number, in this case, the 6th layer. So that puts the 1 over here. And then I'm reversing it so that I have 1s in everything except this layer. And so using this to cull will cull the 6th layer, and all the other layers are visible. Finally, I'm going to set the camera's position with that geometry that I just did. Its rotation can be an identity. It doesn't really matter since it's taking this picture in the world in all directions. And then trigger the render to CubeMap command of the camera that puts that CubeMap into the temp CubeMap material that I already made, and I assign that to the material, and away we go. The complete code looks kind of like this. In Start, I set up various things, make the material, make the camera, and start an update texture coroutine. Make camera just sets up that camera. Make material just sets up the material. And in the update function, I've got R and T keys that double or halve the resolution, setting re-render to true. And if re-render is true, it makes a new material because I've changed the resolution. And it calls the render me function and sets re-render back to false. Now, the render me function is in that coroutine update texture that I started back here in start. And in this case, it's just a while true loop that calls the render me function and then waits for a certain amount of time so that I'm not updating this every frame. I'm updating it at a specific interval. And the render me function does the geometry, getting the new P, putting the camera in the appropriate position, maybe making a marker that shows where the camera is, and catching last position and last rotation for reasons that I'll show you in a little bit. Quite simple. Now, this is very inefficient because that CubeMap capture is happening every frame, even when you're not looking at the mirror. So we can make this much more efficient by using the renderer is visible property. This tells me whether my mesh renderer can be seen in any camera. And this would apply to an overhead camera as well, so be careful with this. But all this means is that only when the camera is visible, when the mirror is visible in a camera, will I bother to call that render me function that does all the work in specifically the render to CubeMap operation that is so expensive. Now I can be even more efficient by recognizing that if I'm behind the mirror, that is I'm outside the room that the mirror is on, or I'm behind the wall, I don't need to compute the mirror, so I can test if I'm in front of the mirror. And if I'm in front of the mirror and I'm pointing the wrong way, then I'm not seeing the mirror, so I can also test if I'm pointing the right way to see the mirror. And I can also test to see if the mirrors can see each other. And this way I can put more than one mirror in a scene and they'll reflect each other. And so I have these functions in front and pointing the right way. In front uses the dot product of the mirror normal and the vector to the camera. If I'm in front of the camera, this dot product will be positive. And the pointing the right way takes advantage of the fact that the dot product of the normal and the camera's forward direction will be negative if I'm looking at the mirror. So just a little geometry there, quick tests with the dot product. An additional efficiency, and the reason that I caught that last position and last rotation in the render me, was if my character has not moved, that is, the last position is the same as it was the frame before, or the last time I called render me, I just return. And if the camera has not turned, the last rotation will be the same, and so I will return. So this doesn't do this work if my character has not either turned or moved. So let me show you these, some examples of these. I don't know where I am here. So first of all, let me show you, first of all, a scene here where I have a mirror made with a reflection probe. I just put a reflection probe in the bottom of this mirror, and it sort of works like a mirror, but you can see that it's not really correct. As I get further and further away, my image in the mirror does not get smaller and smaller, which is wrong. Here it is using a camera that's been placed in the mirror, and it too suffers from the same problem, that I'm taking the picture from a given spot and not from where it should be to get the proper perspective. And over here, I have a couple of different versions of the dynamic material and in particular, this coroutine version, which is the one that I showed you. And here I can change the resolution here. Now I'm at 1024, shows down here. Uh, and if I go T, it's 512, 256, 128, 64. And I think that's as low as I go. These are big mirrors, so obviously you need a fairly high resolution, but it does have an impact on the frame rate. Notice when I turn my camera, my frame rate drops way down, as all of these guys are refreshing their cube maps when the camera moves. So here's version 2 and 3. I'll let you look at them. Coroutine is kind of the one that I showed you. And here in this version, I've got the little marker out here. This is where the camera is. It's using that perfect reflector to decide where to take the picture that it's going to map onto my object here, which has a resolution of 1024, 512, 256, and so forth. Here's a mirror done with reflection probes. So it does work. In this case, my mirror is a standard shader shiny material, very metallic, very smooth. And I'm moving my reflection probe. There's the reflection probe over there that is moving around to the appropriate location where it's going to generate the proper image. And you can kind of see some of the lag there as this thing is, I forget whether this is how this is time slicing, but clearly it's a little laggy. And it has an even worse problem that if I have two mirrors, now I'm picking up blended information from both the probes. And so I have this kind of ghosty image and I can't really see the other mirror. And there are a lot of problems with this. So the reflection probes mirrors don't work. Here's a lot of mirrors done inefficiently. So my frame rate here is 16 to 18. It works, well, sort of. There's some problem here. I'm not seeing the other mirrors, but it's definitely killing my frame rate. And if I go to lots of mirrors with the coroutines, first of all, when I'm not looking at the mirrors, they're not being calculated at all. I'm getting fantastic frame rate. Of course, if I go in here and start looking around, the frame rate drops down because I'm using high resolution textures, 1024. If I drop that down to 512, my frame rate is now 60 or so when I'm moving. And if I drop it down to 256, I'm getting 70 or 80 even when I'm moving around. But of course, it looks prettier with these big mirrors if my resolution is 1024. I believe there's a 2048, but that was too much. So that's lots of mirrors. Now, I set out to do this because I thought it would be really cool to have a mirror maze that you could wander around in, like at the amusement park, and it didn't work. It just didn't work because these mirrors are seeing each other's backs, and the culling is just not set up so that they can see each other. Maybe if you did this with one-sided planes or quads, it could work, but clearly we're seeing a lot of artifacts in here. And so my idea for a mirror maze was a complete bust. That's a little better if the mirrors aren't perfectly facing each other, although there's still plenty of artifacts here that have to do with the cameras seeing the backs of other mirrors when they render their textures. And that's not a good thing. They can only cull themselves. And finally here, here's a kind of interesting wall of, curved wall of mirrors. And we're seeing all the different mirrors as we go around here and all the different objects. And it clearly works. There are various artifacts, and of course it kills the frame rate if you're moving or turning. But if you're stationary, it doesn't cost that much. Great. So I'm going to stop there. I'm going to stop the sharing here. I believe that's all. Yeah, I'm going to stop the sharing here, and I'll end the recording, and I'll see you in class. Bye.